Number 48. What is the maximum number of electrons that can be contained in each shell? I'm going to underline these. Shell, subshell, or orbital. Now, you're given 6 to do. And what are these talking about? Well, these are where the electrons go around the nucleus. And remember, electrons occupy orbitals around the nucleus, and those orbitals are grouped into subshells, and those subshells are even further grouped into shells. And you can perhaps get a better understanding by looking at figure 2.8 here in the textbook. This lists all of the orbitals that surround the nucleus of an atom. And it even groups them into subshells and in shells. So what an orbital is a single box. So I'm going to write that down. An orbital is represented by one of these boxes. And only 2 electrons per box. So only 2, so 2 electrons max per box, per orbital. What a subshell is a set of boxes that are the same in energy. So a subshell is a set of orbitals, or a set of boxes. So we can find several subshells. Look at these 3 right here. Okay, they're the same in energy. So there are subshell. We call this the 2p subshell. So there are 3 orbitals in the 2p subshell. The 3d subshell has 5 orbitals. The 4f subshell has 7 orbitals. Look at these s subshells. Each one only has 1 orbital. So, hopefully you see the pattern. S subshells have 1 orbital in them. P subshells always have 3. Ds have 5 orbitals, and Fs have 7. Okay, and then finally, a shell is a set of subshells. A shell equals a set of subshells. And there are, let me colorize this. So you got shell, subshell, and orbital. Okay, the shells are noted by the numbers here. So the first shell is just this one right here. All it has is just that one, just that one s subshell, which only has itself 1 orbital in there. The second shell is bigger. It contains all of these, which start with the number 2. So it has the 2s subshell with 1 orbital, and then the 2p subshell with 3 orbitals. So 4 orbitals total in the second shell. The third shell is even bigger. As you go higher in shells, you get more subshells and hence more orbitals. The third subshell has 3s. The third shell has the 3s subshell, 3p subshell, 3d subshell. So that's 9 orbitals total. And then you got the 4th shell, the 5th shell, 6th shell, and 7th shell. So 4th, 5th, 6th, and finally 7th. And all these shells are surrounding the nucleus, so lots and lots of orbitals around the nucleus. Okay, I think we can answer this question now. So what is the maximum number of electrons that can be contained in the second shell? So let me underline this one. We're working on A now. The second shell. Where is the second shell at? That's the set of so the second shell is all of these guys. Okay, so how many orbitals total in the second shell? You got 1, 2, 3, 4, and each one holds 2 electrons max. So that's 4 times 2, 8 electrons. I'm going to write number 8 here. That could be in the second shell. How about the 3s orbital? Now, orbitals only hold 2 electrons. So it doesn't matter if it's a 3s orbital or a 4f orbital or a 5p orbital. The 3s orbital is this one. It can only hold 2 electrons. The 4f orbital, you got a bunch of these, but each one only holds 2 electrons. In the 5p orbital, you got 3 of them, but each one only holds 2 electrons. So I'm going to write that down over here. 2 electrons for the 3s orbital, 2 electrons for the 4f orbital, and 2 electrons for the 5p orbital. Okay, so we got 2 more left. The 3p subshell, that's these right here. Okay, there are 3 orbitals in there. So the 3p subshell can hold a max of 6 electrons. And then finally, the 4th shell, oh, I forgot to check these off as we're going. So the 4th shell, let's work on this one. That's all of these guys. Whoops, all of those guys in here. So you got 1, 2, 3, 4 subshells in the 4th shell, but a total of 1 plus 3 is 4, plus 5 is 9, plus 7 is 16 orbitals. Each one holds 2. That's 32 electrons max.